research. I assume you have your students doing writing of papers, drafts, and what have you. But as to new faculty members today, how should you communicate, or what advice would you have for communicating your science?
Well, first of all, they should be going to meetings, and some of those meetings they should be there to learn, and perhaps not necessarily talking right away, presenting right away, but definitely in their overall picture, their big goal should have various vignettes that they can finish in a reasonable time. Remember, when tenure comes, there has to be papers out there that have been reviewed. So in putting together their research projects, their research goals, it should be something important, something significant, but within that, select out the small parts that can be finished. Always completely, as complete as can be at this moment in time, but don't feel that you have to write 20-page papers. Get something finished.
Do you think that there's too much of a driver today with regard to application rather than fundamental science in the work of people, or how they're framing what they're doing?
Yeah, for me, it's never been an issue. I've always not had a conflict between doing fundamental science and seeing an application. But I think, yes, one should be careful then to choose an application for which they're not capable of making very fundamental contributions. You know, as things go in and out of fad, one has to be very careful that they have the expertise and the ability to make serious contributions to those areas prior to worrying about the application. Being always involved with catalysis, et cetera, there's always been a direct link to some application. And that's become more prevalent in my research now with green, sustainable type chemistry that we're doing. But I think there needn't be a real conflict.
I think that's an important point that you just raised in terms of choosing an area or choosing a problem for which you can do both fundamental science and have the potential application, and that the two can feed off of each other well. How about funding today?
Well, you know, the traditional way is to have the good ideas and to write the good proposals to the 3 or 4 major funding agencies. I think connected to this is the network that the young person might be developing as they choose projects within a community of scientists. Again, not repeating everything that's in that community, but finding their niche and getting to know people, developing colleagues, developing collaborations perhaps, but certainly developing a network of people that you can talk to. And this will help in the maturation of their ideas. And serious collaborations can be greatly helpful. I have a serious collaboration with my call in my department, and that is very good for both of us, I think. In my early days, I had Jack Halpern sit down with me, and I went over my ideas, and he encouraged me. And that was a mentor type thing that gave me confidence in writing proposals. I think the elegant experiments will always be honored with dollars. So whether it's, you know, strictly applied or not, if there is a need for something to be done that will make science progress, that will be honored, rewarded.
hope it's true for the elegant ideas.
Yeah.
Before the
Yeah,
elegant results. Yeah. Don,
Yeah.
your thoughts?
Well, I think, certainly I've seen what a community can do for you, because it was very late in my career that I got involved with the polymer community. And it takes a little while to get accepted. I mean, when I submitted my first paper to macromolecules, it did get accepted, but it was a little bit rockier than normal because I was sort of entering a new area. But the community has been very welcoming and have taught me a lot. At the same time, I think, and this might be an issue with young faculty, often they're a little bit inhibited about taking a lot of mentoring from their colleagues because they're worried too much about their colleagues being judgmental. So they often are not as interactive with their senior people as they probably should be. I think we can give good advice. But I think what Marcetta said about the community is extremely important. I have a very supportive community in this polymerization community. Chisholm, Coates, Nosaki, Lou, all over the world we interact. And I think it makes it fun because we're competitors, but at the same time, we're friends and we're scientists with some sort of a common goal to solve major problems. And that I find to be extremely rewarding, and that's happened later in my career than in the beginning of it.
How do you think chemical research will change in the future, especially from what it was when we started?
Yeah.
But projecting ahead, how do you think chemical research will change? And I think, Marcetta, you hit on what some of the enduring qualities have to be. So let me ask you that. How will it change?
Well, one thing that worries me a little bit is that we become too organized into large groups that are somehow interacting via internet or what have you in a very formal way. I think good research is always going to be done by individuals. They should obviously be interacting, and I think interactions, for me, have always been natural. If I need to know something from someone, I send them an email or I call them. And I don't have a formal relationship with them to interact. So I worry a little bit if science becomes too much as a group interaction, that it will somehow inhibit these individuals from, going in various directions, which often are very, very fruitful directions. But I suspect it will change because it's just a lot more interdisciplinary. We're working on bigger problems and problems that one person can't possibly address alone. So I think that's where the bigger changes are going to come in how we handle that to still keep PIs, principal investigators, funded so that they can develop to be really strong contributors to any group interaction. That's going to be critical, how we solve that issue, because the funding level is going to, those two areas are going to be in conflict for the same funds.
I take your question a little bit differently in terms of the type of chemistry that we're doing. If I look through my career, I saw at first physical methods were coming in, and X-ray crystallography was really difficult. I had to bribe Jerry Atwood with cases of beer to get my structures done. But then it got really, really easy, and we got wonderful infrastructures that can support the spectroscopy, the crystallography, and so forth. So synthesis and characterization has become extremely easy, and a lot of work is just in that. But I think we go through another phase where reactions and reactions mechanisms will become what we have to do, what we have to understand. And that will probably involve a new wave of fast kinetics, instruments that we can more carefully monitor what's going on in that reaction profile. And I don't know what instruments, what spectroscopies and what techniques are going to be around the corner, but I suspect there should be some new ones.
I think there are threads from both of what you said. Don, if I have it right, and I tend to agree with you there, the best collaborations are one-on-one and bottom-up as opposed to necessarily top-down. Would that be?
Yeah, I think sometimes forced collaborations, you don't really get your money's worth from them. I always find that if I have this strong interest in solving a problem, I'm going to get the most out of it, and people are very willing to interact. We don't have to pay them to interact with each other, because we want to solve our problems, and that's the driving force, so we're going to interact.
The other part is, you know, the user interface for all these techniques, for X-ray, for DFT, for NMR, has become so easy that students today are asked to work on projects of greater scope than we did. You know, a couple of crystal structures, we could get a thesis 40 years ago, but now that's not the case.
Right.
So we asked them to really do a greater scope, and this then necessarily takes them into a collaborative mode.
Right, and I do have to say that centers for special spectroscopies are really needed. EPR at an advanced level, for example. I mean, I spent my first 30 years of my career avoiding radicals, and now everything I do has unpaired electrons in it. So I really need EPR, I need Mossbauer, and I have to collaborate outside for those. We have collaborators in Germany. I wish there was more money for travel, for students to travel and stay at places. I think there's some modes of funding that needs to be addressed at the national level that will allow more of that to occur at the student level, other than just my grant funding this. There could be student applications for travel funds.